Namaste everyone. Here is a problem. Um, Calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter to steam at 100 degrees Celsius at atmospheric pressure. And a lot of things are given: specific heat of capacity of ice, capacity of specific heat of water, latent heat of ice, latent heat of vaporization. Everything is given. Now, let us not worry about all the data. So, let us see how to convert this 3 kg of ice at minus 12 degrees Celsius to 100 degrees Celsius. Steam. So, how many processes you will get in between? So, what are the changes that are happening in between? You have to supply heat energy for all those changes. So, we'll write it step by step. First step, you have to convert 3 kg of ice at minus 12 degrees Celsius to 0 degrees ice. So, that is the first step. So, minus 12 degree Celsius ice to 0 degree Celsius ice. That is the first step you have to do. Secondly, you have to convert 0 degree Celsius ice to 0 degree Celsius water without changing temperature. Of course, temperature doesn't change when ice melts into water. So, minus 12 degrees Celsius ice to 0 degree Celsius ice. Then 0 degree Celsius ice to 0 degree Celsius water. And mass of the ice and mass of the water will remain the same. Same ice gets converted into water and water to steam. So, mass remains the same throughout. Third process, 0 degree Celsius water to 100 degrees Celsius water. You have to heat it up to 100 degrees Celsius water. And finally, fourth step, you have to convert 100 degrees Celsius water to 100 degrees Celsius steam. Again, here all the heat energy supplied is used to convert water to steam, but there is no change in the temperature. So, starting from minus 12 degrees Celsius ice to 0 degrees Celsius ice, then 0 degree ice to 0 degree water, then 0 degree water to 100 degree water, then 100 degree water to 100 degree steam. So, how are the formulas for converting each from one state to another, increasing the temperature? How will you write the formulas? You know, the amount of heat energy used to raise the temperature of any form of a substance is ms delta theta. And if you want to convert minus 12 degree ice to 0 degree ice, the amount of heat energy supplied, I'll write it as Q1, is mass of ice into specific heat of ice into delta theta 1. Delta theta 1 is minus 12 to 0. Minus 12 degrees to 0 means final minus initial 0 minus of minus 12. That we'll write later. Q2, 0 degree ice to 0 degree water. Mass of ice into latent heat of ice. Latent heat of fusion of ice. Latent heat of fusion of ice. S. Q3, the amount of heat energy required to convert, to raise the temperature of 0 degree Celsius water to 100 degree Celsius of water. Mass of water, specific heat of water, and the temperature difference, 0 to 100. The fourth step, you have to convert 100 degree Celsius water to 100 degree steam. So, mass of water into latent heat of vaporization of water. So, this is how we have to do. And every time the mass of ice, mass of ice, mass of water, the mass of steam, everything is 3 kg. That doesn't change. So, if we want to write the total amount of heat energy required, so I can write the formula like this. Yeah, Q is equal to that Q1 plus Q2 plus Q3 plus Q4. That's what you can write. And mass is every time it is, so I can write mass into specific heat of ice into delta theta 1 plus mass of ice again, it is written outside, latent heat of fusion of ice plus mass of water, it is written specific heat of water into temperature difference second, that is from 0 to 100 degrees Celsius plus mass of water is already in the outside bracket, latent heat of vaporization. So, the total amount of heat energy required is 3 kg into specific heat of ice. Specific heat of ice is given 2100 joule per kg per Kelvin. 2100 into temperature difference is delta theta 1. You have to increase from minus 12 to 0. So, final minus initial. Initial is minus 12. So, first part is over. Latent heat of fusion of ice. Mass is already written outside. Latent heat of fusion of ice is latent heat of fusion of ice is given here. 3.35 into 10 to the power 5. 3.35 into 10 to the power 5 plus here specific heat of water and delta theta 2. Specific heat of water is given 4186. 4186 into temperature difference 100 to 0 to 100. So 100 minus 0 plus latent heat of vaporization. Latent heat of vaporization of steam is given 2.256. 256 into 10 to the power 6. So everything is substituted now. Okay, so you'll have to solve it now. Q is equal to 3 into. So this is 0 minus of minus 12 is 12. 12 into 2100. So it's 1200. 1200. 12 into 1 is 12. 2. 1 in hand. 12 into 2 is 24. 24 and 1. 25. Right. Plus. So as far as possible, we won't use calculators. 12, 0, 12, 1s are 12, 2, 1 in hand, 12, 2 are 24, 25. 3.35 into 10 to the power 5 plus. Here it is 4, 1, 8, 6 and 2 zeros because you are multiplying by 100. 100 minus 0 is 100 plus 2.256 into 10 to the power 6. Yes. U is equal to. So let us convert everything to the same 10 to the power. You can do it by putting everything in 10 to the power 5, I think, or 10 to the power 6, whatever it is. I will put 10 to the power 5. 3 into. Here 1, 2, 3, 4, 5. It will be 1, 2, 3, 4, 5. 0.25 into 10 to the power 5. 0.25 into 252 into 10 to the power 5. Or shall I take 10 to the power 5 outside everywhere so that I need not write it here and there? Okay, I'll write it outside the bracket into 10 to the power 5 everywhere. Plus, this is however in 10 to the power 5, 3.35 plus here 1, 2, 3, 4, 5. 4.186 into 10 to the power 5 plus. So if I want to write this as 10 to the power 5, 110 I would remove 22.56 into 10 to the power 5. Everything is having 10 to the power 5. So what is the answer? So you use the calculator. Clear? Okay, it has to be used now. 10 to the power 5 is not here. 0.252 plus 3.35 plus 4.186 and plus 22.56. That is equal to 30 point and into 3, yes, into 3. That is equal to 91.04 into 10 to the power 5. 91.044. So 91.044 into 10 to the power 5. This is the total amount of heat energy required. So first of all, you have to make a list of the things that you have to do. Or if you want to convert 3 kg of ice at minus 12 degrees Celsius to 100 degrees Celsius water, what are all the processes you will come across in between? Write each process one by one, stepwise, then find out the total energy required to convert completely from minus 12 degree ice to 100 degrees Celsius steam. This is the final answer. Thank you.